Let's take a look at how restricting the domain of a function can actually help it going from something that was not, did not have an inverse or was not one-to-one, turning it into something that is one-to-one. So look, f of x equals x squared. We've already showed this is not a function that has an inverse because it fails the horizontal line test. But what I'm going to do here is I'm going to restrict the domain. So what I'm going to do is I'm going to say that my function f of x is equal to x squared for only the values x greater than or equal to 0. So what that means is in my picture, my picture only exists for positive values or x is equal to 0. So that means our picture actually only looks like this now. If we do that, then you can see it is a function and it has an inverse because it can pass the horizontal line test. If that's the case, then we'll be able to find its inverse. What we can do is switch our f of x equal to y, right? We can switch our x and y variables. Now we can solve for y by taking the square root on both sides. Okay, now we know that when we do square root, we get plus or minus, right? And the right side is y and the left side is plus or minus x. But remember, x could only be positive. That means that we can scratch the negative here and just say that y is equal to x. I'm sorry, I forgot my square root there. Y is equal to the square root of x. So that is the inverse function. F inverse of x is equal to the square root of x. So as long as we restrict the domain of our function to only values of x that are greater or equal to 0, we can come up with an inverse function. And therefore, if we sketch the inverse function, which I'll let you do on your own, it looks something like this. Again, it's a reflection. You could do ordered pairs and change your coordinates and stuff like that. Now, is that the only way we could restrict the domain? No. We could have done it this way. We could have, instead of looking at our original x squared and saying only positive values, we could take all x values less than or equal to 0. And that would give us the left side only. Again, that's a function, and it passes the horizontal line test, so it has an inverse. I go through the same technique to find the inverse, except at that last step when I had y is equal to plus or minus the square root of x, what we would do is we would say y is equal to negative square root of x, and that's because now we want negative values because we are restricted, right? We're restricted to only negative values. And if you were to graph that, or actually let me write down f inverse is negative square root of x. If you were to graph this now here, what you would get is something that looks kind of like this, and you can see over the diagonal that's a reflection. So restricting the domain is one way to get past that whole concept of horizontal line test. If you do it correctly, you can take many functions that originally did not have inverses, and you can actually come up with an inverse for that function on that restricted domain.